Hello, and welcome to episode 4 of Adafruit and Digi-Key's All the Internet of Things, a 6-part series that covers everything you need to know about IoT. In the previous episode, we discussed services. Services are what you use to route events to and from your IoT devices, coordinate real-time communication between multiple devices, and record, process, and visualize the data that your things are producing. We also talked about some of the large cloud services, such as Amazon AWS IoT, Google Cloud IoT, and Microsoft Azure IoT Suite. Now, you might find that although these services provide robust security and sophisticated deployment tools, getting started with using their comprehensive technology is intimidating. If only there was some IoT service that proved easy to understand and implement, maybe one with high-quality documentation, with examples, learning guides, and community support. And maybe, just maybe, an IoT service that provides open-source solutions with a low to no-cost point of entry. Well, on today's episode, I'm happy to do a formal introduction to just that, our very own Adafruit IO. Here at Adafruit, we manufacture, support, and sell all of these amazing sensors, LEDs, and robotics. So naturally, we wanted a good way to interact with them over the internet. Now, we've covered a bunch of great services for data logging and communicating with your microcontrollers over the web, but we wanted a service that fits the need of the prototyping and maker community and was designed for engineers of all skill levels. So we decided to build our own system, and that's how Adafruit IO got started. Like many of the services we've introduced, we maintain both MQTT and REST APIs, which is how you'll be communicating with Adafruit IO over the internet. But you don't have to be an expert programmer. We've built robust client libraries with lots of examples, so you can probably start with some ready-to-go code. Once you've got your device connected, you can control and monitor using configurable dashboards. The web dashboards come with a dozen widgets that allow for easy two-way interaction with your devices. You'll get buttons, gauges, maps, sliders, and more. And outside of the dashboard, you can create triggers to, say, email you when your water sensor value goes above 9,000. We are really happy with the way Adafruit IO is coming along. It's available and free for anyone with an Adafruit account. For the vast number of people starting out with IoT, the basic account will do everything they need. And Pro members can get some nifty extras and more bandwidth. This video and guide will go over all things Adafruit IO, including how to get started and use Adafruit IO to make the most out of your projects. And now that you know what to expect using Adafruit IO, let's focus on how to get started. Some services lock you into using just their hardware or transport, but Adafruit IO is agnostic about what it's connecting to. In theory, anything that can send messages over the internet will work, but we do have some recommendations. The Adafruit Feather line of microcontrollers are low cost, have built-in networking and battery charging, and are easy to program with our example Arduino libraries. If you're planning to use Wi-Fi, the Feather Huzzah ESP8266 is a common choice for ultra-low cost, but has few GPIO. For more power, while still keeping that built-in Wi-Fi, the Feather ESP32 is an upgrade with more pins and a beefier chip. The Feather M0 Wi-Fi board gives you a SAMD21 ARM Cortex M0 with a separate Wi-Fi module. Good if you need native USB or have existing ARM code to run and you don't want to use a different core chipset. These would all be programmed in C, C++, or Arduino. If battery life and portability isn't as important, the Raspberry Pi computers and other single-board computers are also a great choice. These tend to have Ethernet as well as Wi-Fi built in, and the Linux operating system will take care of all your networking for you, so it's incredibly easy to get started, and you can use Python, which is higher level and easier to use than C or C++. And of course, you can also use Bluetooth Low Energy and Tether using our Bluefruit Connect app. For that, we recommend our NRF52832 or NRF52840 Bluefruit Feathers. And of course, you'll also need an iOS or Android phone that will stay on all the time to perform the data transfer. There's two halves to every service online. the back end, where data is handled, and the front end, where you use a web browser to interact. For most internet services you use on a day-to-day basis, you don't deal with the back end at all. It doesn't matter how that restaurant got all the dishes listed on their website, as long as you can order them for delivery. The back end is where you'll be sending your sensor data to and from our server. It's literally named Adafruit IO, so it's pretty easy to remember. You can send or receive data in two ways, with REST or MQTT. Which one you use will depend a lot on your hardware, bandwidth, and language needs. We covered this extensively in previous videos, so go back and watch those if you haven't yet. We recommend REST for your first project. It's easier to understand and debug. Either way, once you've picked your hardware and transport, check how you want to program it, and then choose one of our provided libraries. We've got code and examples for Arduino, C++, Python, Node.js, and even Golang. Get started by registering for an account on Adafruit.com. Once you're logged into your account, you can view your Adafruit IO key. If your key is ever lost or compromised, you can always generate a new key. However, you will need to re-update all of your existing projects, so don't share your key. Okay. Let's check out the way we store data in Adafruit IO. After all, that's what we're here for. Data on IO is kept in time series databases called feeds. Each feed contains timestamped data points. Now, those data points don't have to be just numbers, they can be any type of data. But for example, you could store numbers, say for environmental data like temperature or humidity. And numbers can also be used for controlling hardware, say robot motors, throttle, or speed. Human-readable ASCII strings are also common, often displayed either on a dashboard or in the device's display. Finally, binary data can be saved as well. Now, we strongly recommend encoding it in base64 so you can store or retrieve it with REST and JSON, not just MQTT. For example, JPEG encoded photos could be base64 encoded and then uploaded. Or if you have a firmware over-the-air update, you could store it as an ASCII Intel hex file or likewise base64 encode. In addition to the main storage data chunk you want to keep, you can also attach metadata. The first and most obvious metadata is that time the data was entered into Adafruit IO. And this is handled for you when you post data to the feed. We timestamp it. The second metadata is location, where you can set where on Earth the data came from. That metadata is something you have to add yourself. We don't provide a geotagging service at this time, but if you have a GPS module or you can use a GeoIP service, you can add that on every post. Location addition is only possible via the REST API. You can see the JSON format for adding it here. Let's create a new feed to demonstrate how that works. From your Adafruit IO account, select Feeds. Now in Actions, you can create a new feed. Let's create one called Temperature. New feed is created. Now let's show how to add some data. Select the feed, and under Actions, you can add data. For example, let's add the temperature 25 degrees Celsius. That's it. Once you've added the data manually, you'll see the value as well as the timestamp. In this case, it's in human-readable format, graded at the bottom of the feed. Now let's see what happens if we enter incorrect data. Under Actions, we'll add data, but this time, instead of a number, we'll add a string. Notice that Adafruit IO does not do any type checking. It will let you enter any kind of data you like. So you can take advantage of that, or you can make sure that your code filters out any incorrect data. We can remove the incorrect data with the action Remove Selected Data. While I'm here, I'd like to show you that if you ever want to download all the data from your feed, select Download All Data. You can get it as a structured JSON file or as a CSV text file. Of course, now that we've got that feed set up, we'll want to automatically send data from our thing to it. Let's show how to do that with both a Raspberry Pi and Python, as well as a Feather ESP and C++ Arduino. Let's start with a Raspberry Pi with Python. We've already set up the Pi's operating system and Wi-Fi. We'll wire up the sensor over I2C and then run this Python script. For our sensor, we'll use the ADT7410 from Analog Devices, which is a high-precision temperature sensor with I2C interface. This is the code we have running on our Raspberry Pi, written in Python. As you can tell, it's pretty simple. We're going to be using the Adafruit IO REST client. We set up our IO key and the username. That's how we authenticate. Then we connect to the service, set up our feed, add a little bit of CircuitPython library code to talk to that ADT7410 sensor, and then finally in our while loop we simply read the temperature and then send it to Adafruit IO, wait a few seconds, and then repeat. As you can tell, it's pretty simple and works quite well. Once you've got your hardware set up, go to your Adafruit IO account and visit the monitor page. This is where you can see live data streaming in as it's written to Adafruit IO. You can see the timestamp, the feed, as well as the data being written. This is great for debugging your project because you can see data coming in live. And if there's any errors or typos, they may appear in the live errors section. Likewise, here's an example using the ESP8266 feather with an OLED on top and an Analog Devices ADT7410 wired up on a breadboard. With the ESP feather, we're stuck with a microcontroller rather than a full computer, so we don't use Python. Instead, we'll stick to Arduino C++. The trade-off is we have much lower power usage, so we can run it off a battery, and faster boot. But we also have to be more careful with memory and link management. Here's the Arduino code for the feather. Like the Python code, it's pretty simple. We still need our Adafruit IO username and key. This time, because we don't have an operating system to manage the internet, we'll also need to put in the SSID and password. After that, we initialize the sensor and also the Adafruit IO feed object. In the setup, we connect to the sensor, connect to Adafruit IO, and then wait to make sure that we've connected. Once we're connected in the loop, we have an IO run procedure that takes care of background tasks, reads the temperature, and then saves it to Adafruit IO. Afterwards, we just wait and then run the loop again. And as we can see on the OLED, it's also printing out the temperature and sending data successfully. Over at Adafruit IO, go back to the monitor and you'll be able to see the Huzzah temperature data come in, just like you did with the Raspberry Pi. Once you've got your Huzzah or Raspberry Pi sending temperature data to Adafruit IO, you can visit the feed page. Here you can see every single value with the timestamp of when it was received, as well as view a plot of historical data of your entire feed. Now that your feed is running, let's see what else we can do. When you select the feed, you'll have a bunch of options running down the side. Let's go to the first one, Feed Info. This is pretty much what you expect. You've got the human-readable name and then the key. The key is what you're using with MQTT or REST, so you don't want to change this unless you want to update your code as well. You also have the quick URLs and endpoints for MQTT. This is handy. You can just copy and paste them into your code. And finally, the description. That's for you to keep track of what's going on in your feed. Next is privacy. Now, by default, all of your feeds are going to be private. That means only you can read and write to them, and only if you're logged in. If you set your feed to be public, then you'll be able to get the URL from the feed info, and anybody can see the data in your feed. However, they won't be able to write to it. They can only view it. Now, you might think that the privacy is pretty extreme. Either it's completely private or it's completely public. So we have another option called sharing. You can share read or read-writable versions of your feed to other Adafruit IO members. Now, they have to be logged in and they have to have an account to do so, but this allows you to have more control. If you have a friend who you want to also write to one of your feeds, they can do that if you give them permission. You'll have to invite them by username and select whether you want them to be read or read-write only permission. Next up is feed history. By default, feed history is on. That means you're going to have all the historical data that you've pushed to the feed available for you to download or plot or download later. However, you might want to turn your history off. If you do so, you'll only have one data point per feed. However, the data can be a lot larger, up to 100 kilobytes. So if you want to store images or binary data or over-the-air firmware, you'll need to turn the history off if you're using more than 1 kilobyte. Next is notifications. Now, notifications is a really neat service that Adafruit IO has, and a lot of IoT services don't. This will tell you when something goes wrong with your feed. So, for example, if I want to be notified if my feed goes down and no data is coming in for 10, 30, up to 7 days, I can set that up, And when I create it, I will be notified by email if the feed goes 30 minutes without an update. Here's an example of an email that Adafruit IO sent me when my Huzzah temperature feed went down for over 10 minutes. Let's skip webhooks and go straight to disable feed. Unless you have an Adafruit IO Plus account, there is a limit of how many feeds you can have. Instead of just deleting the feed, you can disable it. However, once it's disabled, you can't reactivate it. However, a disabled feed will allow you to download the data before you delete it. Finally, there's licensing. Now, if you have your feed with public data, you may want to select a license that tells people how you expect that data will be used. We have a variety of Creative Commons licenses available. If you're interested in what these mean, go visit creativecommons.org. They've got great tutorials on all the different Creative Commons licenses available. Okay, finally, let's zoom back to webhooks. As we mentioned in earlier videos, nearly every website and service on the internet has ways to communicate with other sites. Now, while REST is common, again, you can only pull data over REST, which makes it a high-traffic protocol when you're constantly polling for new data. Webhooks are how REST API supporting sites support data pushing. For example, let's say you wanted to get a user's latest Twitter message. Instead of constantly connecting to the Twitter API every minute to check if a new message has been posted, you can ask Twitter to update a webhook URL on each post. That means Twitter will contact you and your server when there's new data. But as you can imagine, you need that web server to listen for that posting. In this case, Adafruit IO can act as that webhook destination for you. Let's show an example. Adafruit IO only supports receiving data at this time. We need a service that will publish data into a feed. Now select webhooks. You can create a new webhook URL for your feed. We have some expiration and data rate limits. We'll use the default. You'll get the webhook URL at the bottom. Now, if you happen to be able to control the JSON data being pushed and you can make sure that the value you want is in the JSON structure under value, you can use this URL as is. Otherwise, you can add /raw to the end to get the entire contents of the webhook event. Or if you just want to be notified that a webhook got pushed, you can add /notify. Either way, copy and paste this URL and we'll add it to the webhook sender. Now we need something to push to that webhook. We're going to use GitHub, which has some amazing webhook integration. Under your account, go to Webhooks and add a webhook. Here, we're going to paste that URL we had from before. And then because we want the full data, we add raw at the end. Make sure your content type is JSON. We don't have a secret. And we'll select a specific event. In this case, instead of push notification, we want to be notified when someone stars or watches our repository. Then add the webhook. That's it. Back at your Adafruit IO page, you'll see the live data come in from GitHub, about 2 kilobytes of data. They're a nice webhook provider. They'll always push an initial hook just to let you know that it's still working. And now, if anyone ever stars at one of our Adafruit GitHub repos, you'll see that action come in with that full payload of about 7.5 kilobytes. You'll see new entries come in immediately. It's way faster than trying to pull GitHub. Now I've got here a Raspberry Pi connected to Adafruit IO that is watching that feed. And it's also wired up to this star. So whenever a new message arrives, it lights up these LEDs to let me know that someone starred an Adafruit GitHub repository, like so. One of the big benefits of webhooks is when you have services that don't update that often, but you want quick updates when they do. Also, most web services require an API or authentication key, which can be really annoying to manage. Webhooks are often free with services, no API or key required. So they can easily provide that glue that integrates with Adafruit IO and other sites with little fuss. Okay, now we've got data streaming into feeds on Adafruit IO and learned all the cool tricks you can do with those feeds. Now the project's data can be viewed and analyzed in real time. If you want to interface with the feed data, you can always query and fetch that data on any computer or device using the REST or MQTT API. And we've got plenty of libraries for every language to do so. Ultimately, almost every Internet of Things project will at some level need to provide a way for the things to deal with the humans. User interface considerations can range from a mobile app that allows a user to turn lights on and off, or maybe adjust the volume on a music player, to output features such as status monitors, analytics, and data visualization dashboards. However, making a custom app with a user interface can be a ton of work. You can create a quick and simple UI using the built-in dashboard capability in Adafruit IO. From your account, select Dashboards, and you can create a new dashboard. A dashboard is just an editable graphical interface web page. Click the plus button to create a new block or element. We have a wide range of really great looking elements that you can add to your dashboard. Of course, you should start with making all your feeds and getting them working well with all that data. Once that's done, you can then visit the dashboard section of the Adafruit IO site. Free accounts can have up to 5 dashboards, and each dashboard can have as many elements as you like. One thing to note about elements as we go through them is that some of them pull from feed data and some push to your feeds, and some do both. We'll explain as we go through them. Note that since all the elements read from the underlying feeds, they can also affect each other, which can be great for adding quick visual feedback. Let's add the first block to our dashboard. We'll go with a line chart, and let's plot that temperature data that we've been saving to our feed. You can select any history amount for your temperature data. Let's do the last 4 hours, and it'll show a line graph sort of like you see on your feed overview page. After you create the block, refresh your page, and you'll see the historical temperature data. You can overlay with your mouse to see the data and the timestamp. The line graph is great for historical data, but if you want instantaneous data, the gauge block might be pretty handy. Again, we're going to display our Huzzah temperature and add that to our web page. This time we show the instantaneous value as it's received, and you can see there's a gauge going from 0 to 100. Once you've added some blocks, you can edit your dashboard and rearrange it, resizing and moving around the blocks as desired. Once you've got your blocks set up, you can also edit them. So for example, on this gauge block, we can change the feed. We can change the min and max values as well to be something a little bit more realistic. And then we can have a preview over here that shows us what it looks like at different values. You can also set low warning and high value warning, so if you want to know if the temperature goes below or above a different value. Now you've seen our gauge block has been updated. You've seen 2 read-only elements. Now let's add a block that writes data to a feed. Let's start with the momentary push button. It's pretty much what it sounds like. When you press the button with your mouse, it'll send one value to a feed, and when you release, it'll send another value. And of course, you can change your color. Now that I've got the button and the feed down at the bottom of the screen, you'll see when I click the button, the on value is written, and when I release the button, the off value is written. So I can tell when I pressed and released the button on my dashboard. With non-numeric data like this button generates, on and off, you can't use the plot or gauge element. So instead, if we want to view that data, let's use a text element instead. When added, it will show the instantaneous value of the feed that it's attached to. So when I press the button, it says on, and when I release, I say off. This is a great way to debug data in your feeds. The text block will show you the instantaneous value of a feed. If you want more data, sort of like the monitor, check out the stream block. When attached to a feed, this block will show you all the data about that feed, including timestamps, the last data written, and a historical list of all data. So, as I press the button, you can see data coming into the stream block, data updating in my feed below, and the text block all updating automatically. You can see here that the feed is written to by one element and read from 2 different elements. Okay, so we've seen some elements that can write to feeds and elements that can read from feeds, but what about elements that do both? Well, let's check out the toggle switch. The toggle switch is kind of a mix of the button and the text element. You can set it on or off, but it will both read and write from a feed. Let's show this off. Now, when I click the toggle button, it will send the on or off signal to our feed, and you can see that over on the text and monitor elements. But also, if I press The reset button, you'll see it updates the toggle button at the same time. So this one will always reflect what's in the feed, and I can write to it or read from it. Here we have a feather huzzah connected to a servo and an LED. The feather is connected to Adafruit IO and listening to a feed called servo, which will tell us where to move the servo, and a feed called LED for whether the LED is on or off. We've also got a dashboard that we've made with a slider element connected to the servo and a toggle switch connected to the LED. Now when I click the toggle, you'll see the LED turns on and off almost instantly. And likewise with the slider, I can change the slider value, and that angle is sent to the huzzah, which moves the servo. As you can see, this is very powerful for making interactive IoT projects. We've demoed a lot of these element blocks, but we're not going to get to demo all of them, so let's just talk about the few remaining. There's the image block. If you've got a feed with base64 encoded image data, this block will actually decode the image and show it on your dashboard. Great for a webcam. The color picker is a read and write element. You can use this to send a color. You can select the color from the web browser and it will send a web hex value to your feed, or it'll read a feed and display the current value. The map element uses OpenStreetMaps to plot the geolocation data attached to your feed. If you need more buttons than the momentary button or toggle element, check out the remote control and number pad. These have 21 and 12 buttons respectively, so a lot more buttons that you can send to your device. And the indicator. This is something kind of in between the color picker and the gauge. It will only show 1 or 2 colors depending on the value of your feed. Good for, green is good, red means stop. Lastly, we've got the icon block, which is kind of an interesting block. Now, this allows you to set the icon based on the text in the feed. So, for example, you want to display a % or an arrow or a paper plane. You can do so by setting the feed text to the static icon value. And, from within the edit block, you can change the color. You can't change the color from within the feed, only the icon. If you'd like to see what icons are available, check out our icons fact. We've got a wide variety available for you, and you can display any of them in your dashboard. While you can build just about any kind of IoT device or project with the feeds and dashboards we've demonstrated, we can add a little bit more logic integration using triggers and services. Triggers are a way to do something when a certain situation occurs. There's 2 kinds of triggers supported at this time, scheduled and reactive. To set up triggers, visit the trigger page from your I/O account. Now, there's 2 types of triggers that you can set up for now. You can schedule them or you can have a reactive trigger. The scheduled ones are the easiest to understand. Basically, you can set up the feed to email you every 30 minutes up to 1 week. All you have to do is select the feed that you want to have emailed and create. Now you'll get an email every half an hour with the value of the pie temperature feed automatically sent to you by Adafruit IO. You can also set up reactive triggers. Now, reactive triggers are a little bit more complicated. First, select the feed you want to react to, for example, the pie temperature. Then you can select a comparison. These are for numeric values only. Now, if the pie temperature is less than either a feed value or a numeric value, you can have it email you if you have Adafruit IO Plus, send a webhook message to a URL, or publish a message to a different feed. When paired with feed notification, you can easily keep track of the health of your feed and also when something's gone wrong. Notifications and triggers are handy for keeping tabs on your feeds, and the webhook capabilities give you a lot of integration options. But you may want to integrate into more services besides emails and webhooks. And sometimes the webhook data is not formatted in the exact right way. Service integration in Adafruit IO lets you supercharge your feeds. Both If This Then That and Zapier are cross-linking services that are popular and wide-ranging. They basically take data and shuffle it between online services. We have integration with both of these services, and best of all, they're free. Once you sign up, you can create triggers much like the ones that are built into Adafruit IO, but with much more control and possibilities. Once you've made an account on If This Then That, you can create your own new applet. An applet is the if this, then that the service provides. First, you have to select the this. Click and type in Adafruit to bring up the Adafruit app. You can then monitor a feed on Adafruit IO, or you can have any new data trigger something that occurs. For example, if you want to monitor a feed, you could check if a temperature is below or above a certain value, but let's go with any new data is posted. Then we can select any of our feeds. They'll automatically appear in the drop-down, let's say the Huzzah temperature, and then we select the that. Now, you can do almost anything from post to Twitter, send an SMS or email, make a phone call, post to WordPress. There's hundreds of different services that are tied through If This Then That, so check them out and see if any of them are useful to you. We'll start by posting to Twitter. Now, you can do a couple different ways of posting, but let's just post a simple tweet. You can change the tweet text if you'd like, and then it will automatically put in the feed name and value from within Adafruit IO. Create the action, and then review it. If any new data from the Huzzah temperature feed is posted, then we post a tweet to @Adafruit IO test. Once you're good to go, click Finish to save it. We've done this Adafruit IO test account, and you can see that the Huzzah temperature is tweeting about every 15 minutes into this feed. Again, this is the easiest way possible to get data from your feed onto Twitter or other social media services. Zapier is similar to If This Then That, so we won't demo both, but they do have some differences in integration capabilities. So we recommend signing up for both of them and seeing which one gives you the connection you're looking for. One thing to note is that both If This Then That and Zapier have some delay to them and limitations. So you won't have messages come and go instantly the way webhooks do. And sometimes there can be up to a 15-minute delay, or even dropped messages, or limited number of messages. So you'll want to do plenty of experimentation to figure out whether it makes sense to use Adafruit IO triggers, notifications, webhooks, Zapier, or If This Then That. Some integrations are available for IO Plus members only. For example, we have a weather service that hooks into Dark Sky, a premier weather forecasting service. Once you start building IoT projects, you'll notice that getting weather data on demand isn't easy. Almost every weather service requires authentication, and most require payment. But with IO Plus and our Dark Sky integration, it's quite easy to get weather data whenever you like, which means that you can make projects that react to current conditions in the local area, forecasts, or really anywhere around the world. Once you've upgraded to Adafruit IO Plus, visit the Services page from Adafruit IO and click on Get Started with Weather. You'll have to add a location. That's where you're going to get the weather and forecast data from. We'll put in Thief River Falls, Minnesota. Once you set the location, you can run our Python demo code to query the weather and forecast. And as you can see, it's pretty chilly over in Thief River Falls. We've gone over just about all the amazing features that Adafruit IO provides, and we're constantly adding more. In fact, there's probably more services and features that we've added since recording this video. You can always get updates on the latest news by checking out the Adafruit blog, and the most recent documentation is available at the URL below. You should now have a good sense of what you can do with Adafruit IO. How feeds, dashboards, and services all work together to get your data stored, plotted, and interacting. Compared to many IoT services, there's a lot you can do for free. So who is Adafruit IO for? The short answer is everyone. Adafruit IO can be used by entry-level makers who want to make a remote control lamp, to advanced engineers who want to automate their entire factory. Scientists could use Adafruit IO to log experiment data in real time and then download or organize gathered data. Home automators can connect sensors to their HVAC system to minimize power usage. Roboticists can control and monitor their mechatronics remotely from around the world. Students can build interactive art creations that tie with social media services and light up whenever their posts get a like. With the powerful single-board computers and low-cost microcontroller boards available, even a first project or a custom one-off product can now be connected and controlled over the internet. We've designed Adafruit IO to be simple and quick to start.
for experimenters and makers of all sorts. Sending data to the cloud is easy to implement with our libraries, so existing projects can be converted easily to an IoT project with Adafruit IO. You can control projects from the internet with ease. Add internet connectivity to household appliances, wearables, art installations, whatever you like. But behind this simplicity, we have made Adafruit IO robust enough to handle the demands of industrial-level engineering without the complexity of enterprise services. We have pre-built APIs to have code communicate with Adafruit IO, data logging, webhooks, and service integration, so you can easily prototype an IoT product before taking the next step and scaling it for production. It's a great place to put together prototypes and build customized projects for small businesses. We'll note that it's not aimed at building and commercializing business-to-customer or business-to-business IoT projects, so check our previous services videos for some suggestions on enterprise-level IoT services. Those will be a big step up in complexity and won't have the same friendly integrations, so they're a good step up once you've got your Adafruit IO project going. If you're curious about what people are using Adafruit IO for and maybe get some inspiration or validation for your ideas, check out our Discord channel at #Adafruit IO, our Adafruit IO forum, the Adafruit blog, and of course the Adafruit Learning System, where we've got dozens of IoT projects with code and wiring diagrams, from the basics of a button to how to automate an entire house. Now you're probably really excited to get started with Adafruit IO, maybe even have some ideas of your first IoT build. The good news is getting started with Adafruit IO is easy and free. That's right, the introductory account that can do just about everything we've shown in this video is free with your Adafruit account. Adafruit IO's basic service gives you 30 data points per minute, 30 days of data storage, 10 feeds, 5 dashboards, notifications, triggers, and most service integrations. After you've gotten comfortable with our basic service and gotten a chance to try out the API and services, you may want more and you're ready to power up. You can upgrade to IO Plus for 60 data points per minute, 60 days of data storage, unlimited dashboards, unlimited feeds, and improved integrations including email triggers and dark skies weather service. You can subscribe monthly for $10, and if you'd like to save some money, we've even got a yearly pass card available for $99 on Digi-Key.com. They'll give you a full year of IO Plus. Each purchase gets you all the goodies we've mentioned, any new service and integrations we'll be adding, and help support and improve Adafruit IO. I hope that after watching this video, you have a better understanding of what Adafruit IO can do for your upcoming IoT project. Feel free to check out some examples of our Adafruit IO learning guides at learn.adafruit.com. And of course, check out the Adafruit blog for updates. Then, visit Adafruit IO and start building your own Internet of Things project today. Join us next time when we will be discussing IoT security.